It probably shouldn't come as any surprise, but Lex Fridman's third interview with Elon Musk dropped a huge number of bombshells. Let's discuss just one little section of this long conversation, which had so many mind-blowing revelations in it that it's worth its own video. For those of you interested in investing, check out WeBull, an amazing platform for buying and selling stocks, and now cryptocurrencies like Bitcoin, Dogecoin, and others. Open an account and get a free stock valued at up to $200, and fund your account and get another free stock valued at up to $2,300. Check out the link in the description and help the channel at the same time. Hey y'all, it's Dr. Know-It-All. So first of all, it's really nice to be back in my studio after a lot of travels. Check out the Tesla tequila right there. Really happy about that. Misinformation got me that for Christmas, so I'm super pleased about that one. Anyway, there is so much stuff to talk about in this interview that Lex did with Elon Musk. I just don't even know where to start. I really want to do an episode just on money. I think the money thing is fascinating. But in the meantime, I just have to parcel this out, right? Because I don't want to have a 5-hour video that talks about the 2.5-hour chat that they had. I will put a link in the description, so of course you can go find it yourself if you're interested in watching the whole thing. I highly recommend it, but obviously it will take time to go through that. It's very long. So anyway, today I want to talk about perception, and I want to talk about what Elon Musk and Lex Fridman were kind of talking about as vector space, but I actually like to refer to as semantics, and that is the perception and understanding of the world and how that's being transferred to AI from human beings. So the section of the video that I'm taking from is from approximately 1 hour and 4 minutes to approximately 1 hour and 21 minutes. You can go watch that whole thing if you want to. I obviously don't want to just like have, what is that, 15, 16 minutes, 17 minutes of Lex and Elon talking on my video. I'll try to keep the clips relatively short, but if you want the full context, I would say start at somewhere around 1 hour and 4 minutes and just watch until about 1 hour and 21 minutes. At 1 hour and 21 minutes, they start talking about photons and all of that stuff. I had another video that I was supposed to be doing today that I've sort of pushed off just a little bit, but that's going to be the very next one, and it will talk about photons, and it's going to talk about Andrej Karpathy. But first, I wanted to talk again about semantics and artificial intelligence. So let's start with a clip that sort of sets this up.
What do you think is the hard part in this whole beautiful, complex problem?
So it's a lot of freaking software, man. A lot of smart lines of code. For sure, in order to have create an accurate vector space. So, like you're coming from image space, which is like this flow of photons, going to the cameras, and and then so you have this massive bit stream in image space, and then you have to effectively compress a massive bit stream corresponding to photons that knocked off an electron in a camera sensor, and turn that bit stream into vector space. By vector space, I mean, like, you've got cars and humans and lane lines and curves and traffic lights and that kind of thing. Once you have an accurate vector space, the control problem is similar to that of a video game.
All right, so really good question from Lex Fridman. Really, really cool and kind of in the weeds answer from Elon Musk. He talks about taking the raw bit stream and turning that into a vector space. So let's start with what he means by vector space first, and this is exactly what I'm going to talk about as semantics. What he's talking about here, of course, the raw bit stream is effectively, let's use a human being. It's the same thing with a camera and a computer, more or less. But essentially what I've got is I've got lights, and the lights are projecting photons into my eyes. They're bouncing off of things. Those things change the color and intensity of the photons, and those things all hit my eyes. That's a raw bit stream of data. That's like stuff that's just coming into my eyes. My brain then has to process all of that and say, like, oh, that's a teleprompter reader. Oh, that's a field monitor. Oh, those are actual lights. Oh, this thing back here is the Tesla tequila, zigzag lightning thing, right? So it's making those changes, and what that is, the vector space that he talks about is a reduction of the raw bit stream. So all of the stuff that's coming into my eyes, again, just using me as a human being here, all of those elements that are coming into my eyes are meaningless. And what I have to do is I have to reduce and reduce and reduce. And this is something that they talk about a lot in this little section, is a lot of the importance of what's going on here is getting rid of. So the important thing is it's feature extraction in neural network speak, but a lot of that means feature rejection. And what that means is you have to throw away the unimportant stuff. So the fact of the matter is that I don't need to look at the fact that there's like dust on the top of my teleprompter monitor. I just noticed that right this second. Hadn't even seen that before. That's unimportant detail for what's going on right now. Take, for example, if you're driving, it's unimportant that there are individual blades of grass on the sidewalk beside the road. What's important is the edges of the road, the curve of the road, the lines that demarcate where the lane is, and any other object that might come into contact with you as you drive down the road. So if you were focusing on every little blade of grass that was out there on the lawn that you were driving past, you would never get anywhere. Your memory would become overwhelmed. Your processing power as a human being would become overwhelmed. So what you're doing is reducing all of that stuff down into a small subset of those things, and those small subsets then become conceptualized. So you might look over there and just glance over and say lawn, right? That whole greenish, well, right now it's kind of brownish because it's wintertime, but anyway, you say that area over there that's that one uniform color is lawn. Unimportant, reject, not important, so throw that away. Other area, this is a curb. Curb continues on into the distance, and because of perspective, it gets narrower as it goes forward from my perception, so that is curb. So we're reducing down to a vector, which is the lawn vector. We're reducing it to the right-hand curb vector, the left-hand curb vector, the steady state area, which is the road surface, the asphalt that's the road, maybe a double yellow line in the middle or something like that, and that demarcates the left-hand edge of my lane. And then things like the front end of the car, which again is unimportant for driving unless you're really, really close to the car in front of you. So under normal circumstances, you reject that. You're not interested in that, but you have reduced that down to the vector of this is the front of my car. This is the nose that's sticking out. You then throw that vector away under most circumstances, unless you're at a stoplight or in a parking lot where you have to actually care about how far your car is. Generally speaking, you stay far enough away that the differentiation between where you are and the front nose of your car is unimportant. So anyway, that's what he's talking about here. He calls it vector space. It is a vector space. Mathematically, what that means, a vector is just a string of numbers. People are used to thinking of like XY coordinates on a map or a Cartesian plane, right? So if you've got a Cartesian plane with like a coordinate axis like this, and you have a point 1, 2, you go out 1 in the X, 2 up in the Y, and you can draw a line, and that is a vector. So that from 0 to 1, 2 is a vector in Cartesian coordinates. In a 3-dimensional space, you would add z. So you might have a z of 20 or something. So it's 1, 2, 20, and that will push it back into the z-axis by 20 units. So that's all a vector is just a bunch of numbers, and that's really ultimately all that a neural network is dealing with, is a bunch of numbers. But what you're getting out of that is a conceptual concept, at least for a human being. And this is where I say that neural networks are quasi-semantic. They're able to reduce these things to vectors, and it might reduce this to a car vector. So it segments the scene out, and it puts it into a little box. And by the way, if you haven't seen these things, I've got a whole series that I did on AI Day where Andre Karpathy talks about that. But essentially, image segmentation is super important. And of course, we've gone beyond individual image segmentation. Now it's video over time segmentation. So that helps a lot. And Lex and Elon talk a lot about that. They talk about the fact that you have to deal with temporal and of course spatial issues as well. And what that means is if something gets occluded, right? So if you're here and there's a car over here and a truck goes between you, you can't forget about the fact that there's a car 2 lanes over, even though the truck is blocking you. So you have to temporarily remember that, but you also can't remember that for too long. And that's something that Elon actually goes into some depth in this particular clip.
Your brain is doing an incredible amount of processing and giving you an image that is a very cleaned up image. Like when we look around here, we see, like you see color in the corners of your eyes, but actually your eyes have very few cones, like cone receptors in the peripheral vision. Your eyes are painting color. in the peripheral vision. You don't realize it, but their eyes are actually painting color. And your eyes also have like this blood vessels and all sorts of gnarly things. And there's a blind spot, but do you see your blind spot? No, your brain is painting in the blind spot. And then even once you get all those vision signals, your brain is constantly trying to forget as much as possible. So human memory is perhaps the weakest thing about the brain is memory. So because memory is so expensive to a brain and so limited, your brain is trying to forget as much as possible and distill the things that you see into the smallest amounts of information possible. So your brain is trying to not just get to a vector space, but get to a vector space that is the smallest possible vector space of only relevant objects. So you're glancing around, and what your mind is doing is trying to distill the relevant vectors, basically objects with a position and motion, and then editing that down to the least amount that's necessary for you to drive.
But anyway, the important part of all of this is that what we've got vectors, right? So we've got a whole bunch of numbers. You can think of it like a database, and each row is a vector, and it's just a bunch of numbers, but those numbers represent something. And ultimately, they are saying, like, within this region, there is this object, and then the quasi-semantic element of that is, what is this object? It then has to identify what that object is. Car, human being, lawn, unimportant, background. I did actually a rather popular video recently about that, where I talked about panoptic segmentation, and Andre Karpathy talked a lot about that. If you haven't seen that, you should watch that, because that goes into some detail about that also. But all of these things are super important because as Elon Musk says, the control aspect of the car is relatively well understood problem. And, they're a robotics company, and they do a really good job. The car drives very, very smoothly in general, even with full self-driving. So that part is a relatively known problem, and they've done a good job of solving it. So the big problem right now is comprehension, and that's what we human beings do. So Elon talks about a baby that you can play, peekaboo like that, right? With a baby beyond, it's something like 6 or 8 months. But at some point, they don't have a persistence of memory. So that when you cover your face, you're gone. Your face is gone. And when you take your hands away, or as Elon says, when you take a toy and you hide it behind your back, that toy has disappeared, or your face has disappeared. And when you open your hands back up again, it's like you have just, like God have appeared from the clouds, and it's for the first time for the baby every single time. And what you'll notice is when you have a child, there will come an age where that peekaboo game is no longer very interesting to that child, because they've crossed over that. They're like, oh, your face is still there. You've hidden it, but it's still there. So they're like, yeah, seen it, right? So when they've crossed that threshold, that's when a human being is perceiving over time and remembering things. There's a persistence of memory and a persistence of vision at that point. But of course, that requires a huge amount of processing power and a huge amount of comprehension and a huge amount of understanding what the world is all about. And all of these things don't come for free with neural networks. So you can do ImageNet training, right? You can do basic convolutional neural networks that will recognize cat and dog and all of that stuff. But if you then take they're not recurrent, so it wouldn't really work this way. But if you could somehow magically do this and have a series, cat, 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 truck goes in the way, cat, 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 the convolutional neural network will have to start from scratch. It wouldn't recognize, oh, that's the same cat as before. It wouldn't have any kind of memory interframe between these frames about what this cat is and if it's the same cat and what it's doing. So all of that stuff is super important for the neural networks that Tesla uses to be able to work properly. Now, in order to do that, it sounds like they have a mind-boggling amount of neural networks that are actually at work.
If you see the full array of neural nets that are operating in the car, it kind of boggles the mind. There's so many layers. It's crazy. We started off with simple neural nets that were basically image recognition on a single frame from a single camera, and then trying to knit those together with C. I should say we're really primarily running C here because C++ is too much overhead. And we have our own C compiler. So to get maximum performance, we actually wrote our own C compiler and are continuing to optimize our C compiler for maximum efficiency. In fact, we've just recently done a new rev on a C compiler that'll compile directly to our autopilot hardware.
So you want to compile the whole thing down?
There's a lot of hardcore software engineering at a very sort of bare metal level, because we're trying to do a lot of compute that's constrained to our full self-driving computer. So, and we want to try to have the highest frames per second possible in a sort of very, very finite amount of compute and power. So we really put a lot of effort into the efficiency of our compute. And so there's actually a lot of work done by some very talented software engineers at Tesla that at a very foundational level to improve the efficiency of compute. And it's like, what are neural nets? It's like, compute-wise, like 99% dot products. So,
and you want to achieve as many high frame rates, like a video game. You want full resolution, high frame rate,
low latency, low jitter.
So as you can hear from this, not only do they have a ton of neural networks working, but they also are operating in C, which makes me a happy camper. That's what I actually learned to program on. I actually learned before object-oriented programming languages really existed. And so I learned on like BASIC and Pascal and C, particularly on C. So even though it's a very old-fashioned language, it's still incredibly powerful. And other things like C++ are, of course, based on C. So there is a lot of overhead with object-oriented languages, and that overhead is really critical when you have time-critical stuff on very, very small amounts of hardware. So again, I think I liken it to a game. So what you're trying to do is get the fastest frame rate possible for the highest quality game that you can manufacture, but you're trying to do it on your phone. So you don't have access to a massive beastly gaming PC with like 4 GPUs running or something like that. You've got to make this all work on this tiny little portable device. And that's what's got to go on here. So it's the same sort of thing going on because your car, the full self-driving hardware 3, even though it's really, really good, is extremely limited, and it's got an extremely limited amount of memory. So they're trying to like compress, make it run as fast as possible. They've got an optimized C compiler that compiles directly to their own hardware. And all of that stuff allows them to squeeze every drop out of the lemon that they're trying to get out of it. And of course, as Andrej Karpathy has talked about before, they refactor their code. So they use really, really massive code to do the training on, but then what they do is they refactor to get it down to something that's adequately good enough. It's not as accurate, but it's adequate for what the car's got to do. So again, we're talking about vectors as an understandable thing. If you create a vector that is a car, a particular area of the video sequence, that's a car, that allows you to have some understanding, because then you can attach that to what do cars do. Someplace out there's got to be some extra memory about what cars do. Cars are objects that can move around relatively quickly. They can change lanes. They can accelerate, decelerate. A car is not a garbage can, right? They potentially might have a relatively similar shape, but a garbage can is not going to move on its own unless it's very windy outside. It's just going to sit there. So you can kind of neglect it, and a car that's parked will also not do things. It's really interesting that Lex Fridman, I have not watched this, but apparently Andrej Karpathy did a whole talk at MIT about doors. And doors are an amazingly complicated thing when you have to do the semantic aspects. So it's not just a car, but when a car is parked, the door can open. And that is a really important aspect of it. In fact, I feel like full self-driving, one of the downfalls right now is that when it passes parked cars, it passes way too close to the car. It's perfectly safe unless the person opens the door, at which point you might hit that door. So as a human being, knowing what I know about potentials for doors opening, I would give perhaps a meter under most circumstances around these cars to make sure that I avoid any potential problem with that. The Teslas do not do that. They make me uncomfortable because they pass cars at such a close range, but again, they're trying to deal with doors. So that's a semantic issue. It's like, okay, here's a car is parked. A car that's parked, semantically, you need to understand someone could open the door, or alternatively, a child could run out from in front of that car. So those are dangerous emergent situations that you have to think about before they happen. So these are predictive things that you can only do once you understand the world. So it's interesting because Elon Musk talks about memory being very expensive, both for humans and for computers. In fact, more so probably for humans than computers. But anyway, human beings are really good at optimizing memory for time and space. And what that means is that, again, as you drive down the road, you don't concentrate on all the stuff that's important. You only concentrate on a few objects, the other cars that are around and potential VRUs, pedestrians or cyclists or something, and objects that could impinge on the road, like a tree branch that's growing too close or something. That's all you worry about. You don't worry about all the other stuff or the sky or all of those other things that are going on. So you're optimizing for time and space. Only the things around you right now. You don't think about the car unless you've got road rage. Don't have road rage. But if you remember that car that cut you off 5 minutes ago, that's not a good use of your memory. You're just cycling over something that doesn't matter anymore. So what you need to do is optimize for a very narrow time and space window. And so you've got only things around you that are close, within a few seconds or maybe 30 seconds in terms of time, and then space, only the bubble around you that you could impinge upon within the next 5 or 10 seconds. So that's all that really, really matters. It's the same thing if you're going skiing or something, right? It doesn't matter if you're driving or skiing. If you're skiing, what you need to worry about is the terrain in front of you and any other skiers and trees and stuff like that. So, right, that's what you need to care about. You don't need to care about the people behind you. Don't need to care about the lift that's going on overhead or something. You need to care about the things that matter right now. So you're optimizing in both time and space. And so Teslas need to do that as well. And one of the things they've got with the new Hydra-net 4D technology is that they are optimizing not only in around them in space, but also through time. They're able to keep track of things over time so that, again, if you have you and another car and something passes between the two of you, you still remember that that other car is over there. But they also have to keep track of space, because spatial is important too, because again, as Elon says, a perfect case of this is you pull up to an intersection with a red light, and there's a bunch of pedestrians over here that are going to cross that road, apparently, but then a truck pulls up between you and those pedestrians. And that could violate your time thing, because you could be sitting at that light for 60 seconds. That violates your 5 or 10 second time window, but it doesn't violate the spatial window, which means that you now have to be paying attention, both as a human being and as an AI driver, to those hidden human beings and expect them to come out and walk across the street at some point. So you need to be paying attention to that spatially as well as temporally. Very, very complicated stuff to do in terms of neural networks and everything. And I think that's one of the reasons why Elon says that they have so many different architectures that they're working on. And I think it's fascinating to hear from Elon that they have re-architectured the neural network stack so many times.
Just imagine there's like a large truck or something blocking sight. But before you came up to the truck, you saw that there were some kids about to cross the road in front of the truck. Now you can no longer see the kids, but you need to be able. But you would now know, okay, those kids are probably going to pass by the truck and cross the road, even though you cannot see them. So you have to have memory. You need to remember that there were kids there, and you need to have some forward prediction of what their position will be.
It's a really hard
at
problem.
The time of relevance.
So with occlusions and computer vision, when you can't see an object anymore, even when it just walks behind a tree and reappears, that's a really, I mean, at least in academic literature, it's tracking through occlusions. It's very difficult.
Yeah, we're doing it.
I understand this.
Yeah.
So some of it...
It's like object permanence. Like an important evolution of the neural nets in the car is memory across both time and space. Now you can't remember, like you have to say, like, how long do you want to remember things for? And there's a cost to remembering things for a long time. So you like run out of memory if you try to remember too much for too long. And then you also have things that are stale if you remember them for too long. And then you also need things that are remembered over time. So even if you, like, say, have, like, for argument's sake, 5 seconds of memory on a time basis, but, like, let's say you're parked at a light and you saw, use a pedestrian example, that people were waiting to cross the road, and you can't quite see them because of an occlusion, but they might wait for a minute before the light changes for them to cross the road. You still need to remember that that's where they were, and that they're probably going to cross the road, type of thing. So even if that exceeds your time-based memory, it should not exceed your space memory.
It's this Hydra-net mini.
Hydra-net.
Yeah.
We're changing the name to something else.
Okay. I'm sure it'll be equally as
Yeah.
Rick and Morty like.
There's a lot of yeah. We've re-architected the neural net, the neural nets in the cars so many times. It's crazy.
Oh, so every time there's a new major version, you'll rename it to something more ridiculous or memorable and beautiful. Sorry, not ridiculous, of course.
If you see the full like array of neural nets that are operating in the car, it kind of boggles the mind. There's so many layers. It's crazy.
So as you've heard, not only have they re-architected the neural networks a bunch of times, and apparently Hydra-nets are now old news, even though that's the latest I heard about, but they have something else that's different than that now operating. But they're also running a ton of C code as well to sort of glue all this together, at least as far as I understand it. Anyway, it sort of boggles the mind thinking about trying to put all this stuff together. It seems like it could be kind of spaghetti code eventually, but I guess they must be really, really careful about the glue that holds all of these different elements together. So anyway, all of this equates to them trying to maximize the frames per second. As opposed to a video game where you're trying to render the maximum number of frames per second, here they're trying to comprehend the maximum number of frames per second. Much, much more complicated thing to do, but it's the same idea. The higher the frame rate, if you can go from 10 frames per second to 20 to 40, every, sort of doubling or even a couple of percent higher frames per second, you are able to go much faster. You'll be able to understand the world much more quickly. So if, for example, you're able to get up to like 50 frames per second, that means that you're down to 20 milliseconds between every update, right? So what that means is you've only got this tiny little 20 millisecond window of time before it makes an update and it understands the world again. And that's critical because if you're going from, let's say it was a 1 second update, right? Take an extreme example. If it was a 1 second update between status updates, that would be fine for driving around at a couple of miles an hour in a parking lot. That's not gonna work at 75 miles an hour on a highway. You've got to be able to react instantly. If you're going 75 and somebody slams the brakes on in front of you, you need to react faster than 1 second. And so if you can do that in a fraction of a second, like 20 milliseconds, if you can see the brake lights go on and you can start to react, you'll be reacting faster than a human being can, because of course we have multiple fractions of a second before we're able to react, but that also just means it's safer. So again, the higher the frame rate, the better everything is, just like with a video game, but it's your life that's on the line instead. And then Elon and Lex get into the whole no post-processing aspect of things, but I'm going to reserve that for the next video because this one is already long enough. But anyway, what we're talking about here, everything that they say, Elon Musk doesn't use the word semantic, but that's essentially what it is. What it is meaning. This vector space he keeps talking about, the reduction to vector space means that what's happening is that the neural network, the brain of your car's computer, the full self-driving computer, is discarding everything unimportant, and it's segmenting out and understanding and recognizing all the important things. Each of those is being stored in kind of a vector or multiple vectors in time and space, and it's holding on to that stuff just long enough to make use of it and make control decisions. So where do I turn the car? How much do I accelerate or decelerate? Can I get over into this lane that I need to get into to make a turn that's upcoming? Things like that. This is all essentially creating some meaning out of the world, and I think that's really cool. So again, the car is not understanding the world as we understand the world, but it's beginning to. It's a narrow AI and it's a narrow comprehension. And Stephen Mark Ryan just talked about how nobody talks about AGI and Tesla, and I actually have talked about that before. So I have talked about that, Stephen. But anyway, I think it's really important to understand that this is not general AI at this point. This is narrow AI, but it's profoundly powerful narrow AI. And what that means is narrow AI is doing a single task. So a really, really single task would be something like just saying dogs and cats, right? That's a classic example. That's super narrow. It can do it really, really well, but it doesn't understand anything else. If you give it a picture of an elephant, it's like, what the hell is that, right? So that's super narrow AI. So this is still narrow AI, but it's a whole bunch of narrow AIs. It's recognizing cars, recognizing human beings, recognizing garbage cans, recognizing the sides of roads, recognizing the surface of roads, on and stop signs, on and on and on and on and on. So it's a whole bunch of narrow AIs that are all being smushed together. And as far as I understand it, I think that's how general AI is eventually going to be solved. We're going to have all of these narrow AIs that will eventually conglomerate to create something that approaches general AI. I just did an interview with Alejandro. I will put that up here. I think he asked me some really good questions. So I hope you enjoy that interview. It's like an hour long. But anyway, I'll put that up here because I talk about this at more length. But I think we're probably about 20 years away from AGI. But I hope that Tesla is in the lead at that point. I think that they are pushing the boundaries as much as possible. I also think that robotics, I think a computer that is like a laptop or something, I don't believe will ever solve general artificial intelligence. I believe that what is going to solve it is a robot, because I personally believe that the only way we really have full consciousness and full comprehension is interacting with the world. So the Tesla bot, something that has sensors in its hands, visual sensors, interacts with the world, that has a much, much higher chance of being artificial general intelligence, of getting to that point, than your laptop ever will, because your laptop doesn't really interact with the world. It only interacts through a keyboard and potentially a video monitor. But I think the physicality of robots are critical to solving AGI. And I can go into that. If you're interested in hearing more about that, and I can talk more philosophically and speculatively, definitely let me know in the comments. Anyway, in the meantime, thank you all so much for watching. I hope you enjoy this episode. If you do, please like it, because YouTube's algorithm kind of depends on that. And of course, please consider subscribing for more of this kind of content. It really helps the channel a ton. As always, a huge shout out to my patrons on Patreon. Thank you all so much, especially during this holiday season where things have been so chaotic. I really have appreciated the Discord discussions that we've had, and the Patreon messages you've sent me, and just the support in general for while we've been traveling and things have been chaotic. So thank you all so much for that. And if you're interested in some awesome merch, check out the link in the description. We've got the Tesla Bot t-shirt, which is super popular these days. Don't mess with Tesla. Lots of other t-shirts, tumblers, mugs, etc. So check out the link in the description and help the channel out. And for those of you interested in investing, check out WeBull, an amazing platform for buying and selling stocks, and now cryptocurrencies like Bitcoin, Dogecoin, and others. Open an account and get a free stock valued at up to $200, and fund your account and get another free stock valued at up to $2,300. Check out the link in the description and help the channel at the same time. Thank you. And finally, don't forget we are both Tesla and Amazon affiliates. If you look in the description, you can see how going shopping for a solar roof, a power wall, or anything on Amazon really helps out the channel. And as always, feel free to ask me questions in the comments or at my email address, which is drknowitallknows@gmail.com. Till next time, bye-bye.